Hey everybody, Hank's back, and I want to talk about one more awesome new thing I learned about while working on the Cisco NX-OS NetBox Sync utility, Genie Conf. Now I've talked about in a lot of videos about how awesome pyATS and Genie are for learning about the operational and configuration state of your network so that you can build validations and health checks and profile before and after changes. But Genie Conf also allows us to send configurations to our network in a very Pythonic, non-CLI driven way. Let's take a look at how I'm using it inside of the utility. So over here, I've got IPython set up on the left side of my screen, and this is where we're going to be interacting with Genie Conf. And over on the right side of the screen, I've SSH'd into the DevNet Sandbox always on NX-OS switch that we're going to use for this demo. So let's go ahead and connect to the device and establish that initial connection. All right, so we're now connected to the device, and we can start our process of actually using Genie Conf to make changes. Now, the first thing we'll want to do is we're going to add a new VLAN using the Genie VLAN object as that's part of the model. So we'll go ahead and import that in. So from genie.libs.conf.vlan, we are going to import the VLAN object. Now we're also going to manipulate and work on interface configuration, so we'll go ahead and we'll import that library as well. libs.conf.interface import interface. So that gives us two objects inside of Python that we can work with. We'll start out with the VLAN. We'll say we're going to create a new VLAN, and we'll use the VLAN object we created. Now the key properties for a VLAN are the VLAN ID, so we'll say that equals 3001, and then the name will be Genie configured for the VLAN name. Oh, look at that. Name equals Genie configured. All right, so we now have a new VLAN object inside of Python, but we haven't said which device this belongs to. So we'll go ahead and we'll add this to our device. So we'll say device add feature, and then we just provide the feature that we want to add in this case, new VLAN. Now what's interesting here is, let's say I had an entire test bed made up of multiple different devices, maybe even of different operating systems. I could add that feature to the entire test bed set of devices, and then this VLAN would be prepared to be configured on all of them as they go through. And because we're using the underlying models inside of Genie for a VLAN, we don't have to worry about creating VLANs differently on iOS versus NX-OS versus XR and other platforms that support that model. Now we've added it to the device inside of Python. Now we actually need to push the configuration out. But before we push it, let's see what the actual configuration on the switch is so far. So we'll switch over here and say, okay, show me show run VLAN, and let's make sure 3001 doesn't already exist. Indeed, it does not. We can see we've got VLANs up to 105. And so what configuration is going to be pushed out by pyATS and Genie based on this configuration line I put in? Well, let's take a look. So let's see what the output configuration will be on the new VLAN, and we'll say build config. But I don't actually want to push it yet. I just want to see what the config will be. So I'll say apply equals false. Now I can do a print output, and then that output is going to contain the configuration for any device that this feature has been added to. So we'll say we want to print it for our device that's here, and let's take a look. Well, not a huge surprise here. This is the configuration necessary to create that VLAN. And so we can take a look at the config before we push it. And now to actually make that configuration change, we can go ahead and run the output, but this time we'll say apply equals true. Now that is also the default state for this function, so we wouldn't have to provide it at all, but we'll be explicit here. I'll push that out, and we can watch as Unicon or pyATS is already connected to the device, but pushes those configurations out as they go through. If I come back to my switch over here, we do our show run VLAN. Now we can see that the VLAN 3001 has been configured. Now we've seen the configuration. What if we actually had a VLAN that we wanted to remove from the device? Well, we can do that with build unconfig. So I'll go back into output, say new VLAN, build unconfig, and once again we'll do our apply equals false so that we can just see what will be pushed out. We'll find that print statement again. And here we can see it'll push out a no VLAN 3001 to remove it. Let's test that out. So we'll say output equals new VLAN dot build unconfig. And again, like I said, apply equals true is the default, so I won't even include it this time. Push that out. We can see no VLAN 3001. Back over here, show run VLAN, and it's no longer on the switch. So this is really nice. I've been able to use very Pythonic, object-driven configuration to push out those pieces that are needed based on the models that are supported for the VLAN on the switch. Now let's look at interface configurations in a similar fashion. Now we're going to do new interface equals interface, and then we're going to say name equals Ethernet 110. Now for an interfaces have to exist on a device, like that's a reference specifically. So we do have to set which device that we're creating this new interface on. So device equals device. So I've now got my interface that's there. Now we can set some configurations details about what we want our interface to look like. So we can do new interface dot description equals, we'll say Genie set me. We can say new interface dot enabled equals false. We'll say we want to configure it, but we want to shut it down. We'll say new interface dot switch port enable. So do we want this to be a layer 2 or layer 3? We'll say switch port enable will be true to make it a layer 2. New interface dot, I think we want switch port mode equals trunk. We're going to create a trunk interface. New interface dot native VLAN equals, we'll make it 101. And then new interface dot, we'll say trunk VLAN. So what VLANs do we want trunked? Equals 101 through 105. Yeah, that's what we want. And then we will say we've got that all prepared and ready to go. So let's look and see what our configuration on the device will be pushed out to be. And so we'll say output equals new interface dot build config apply equals false. And then we can print output, and we can see what configuration will be pushed out there. So we can see here it's going to go into the interface, it'll set the description, shut it down because we specified that, switch port mode trunk, all those details as we specified as they went through. Now we can go ahead and push that config out. Output equals new interface dot build config. We will say actually push that through. There it goes, and we've pushed out our configuration to our switch. The details are in place, and if I go and we look, show run interface Ethernet 110, and we can see our configuration is set as we desired. And we can do those same types of pieces across all the models that are supported within Genie. Let's take a look at what that list looks like. So to do that, we're going to start over here on pyATS's homepage on DevNet, developer.cisco.com/pyats, and we'll jump right into the docs. Now from the docs, what we're interested in is the Genie library guide. So we'll jump over to that. Now inside of the library guide, you'll find all the details about how to get started, use the APIs, use the configuration. But what we're interested in is the available models, and you can see here it's for both conf and ops. Ops are all of those typical learn and parse commands you've probably used before. Config, or the conf object, is what we've been using in this video. So here's that giant list of the models that are supported. Now we've looked at this before anytime that we've talked about Genie Learn OSPF or Genie Learn routing, Genie Learn VLANs and interface. But if we go into one of these, we can actually see that they both have not just operation, but configuration details. And we could look at the GitHub code for those as the parsers and information. But we're going to start out by looking at the model to see how we can see the conf versus ops properties. So here in the model documentation, you can actually see where the pyATS development team decided and picked up information about how to build the model out. You can see that they're leveraging Yang models from the IETF, OpenConfig, as well as the native models for the platforms. But if I scroll through, you'll see all of the documentation about how these models are built, which commands are used to pull specific information and counters and statistics. But what I want to see is the very bottom of this, where it shows what the model looks like. I'll scroll up to the top of the model. And where is it? It's coming up here. The interface model is a big one. All right. So we can see here when we learn all about interfaces, we're going to have an interface object that goes through. And then over here in the comments, we can see that this is an ops or conf object, because both of those it can be either just read or configured. We can see the same thing with description, type, operational status. Operational status is just an ops property, because you can't configure whether an interface is operationally up or down. But the enabled status, that's an ops and conf, because we could shut an interface down or no shut it. That's the admin state, or the enabled status. We can also see things like the access VLAN. This is an operational and configuration piece. And so by looking at the model information, we can determine which parts are configuration or operational only as they go through. But it's the same model whether you're learning about the interface or you're actually configuring the interface, which makes that easy to switch back and forth between the two as they go in. If I jump back here to the actual page, remember Genie, the parsers, the models, these are all open sourced. So if I wanted to see how is Genie actually configuring these on particular platforms, I can look at the configuration. And inside of here, we can see I'm off on GitHub, Cisco Test Automation, Genie libs, and then we're inside of the conf lib for interface. And each one of these folders represents the different platforms that this particular model is supported on. We can see it's supported on iOS, iOS XE, XR, NX-OS, but interface is also something that exists on Ixia devices, Pageant devices, Spirent. And so all of these different devices share that same basic model that gets mapped through. And if I wanted to see how it was done for NX-OS, I could go into the interface. And then just to bring it back to the start of the demo, when I did that import and I said from Genie libs conf interface import interface, this is the actual object that was imported, is right here. This class of interface is what we use to create that interface object that we did our configuration on. All right. That's all I wanted to go through today on this short look at the Genie Conf piece, but hopefully you're as excited about the possibilities here as I am, moving away from all of the CLI-based configuration and being able to have consistent model-based configuration in a very Pythonic way using pyATS and Genie. All right, I'll talk to you guys soon. Thanks.